Hey there, Apano here, and I am back with another video. In the last video I went through introducing the state machine, and so in this video we're going to build upon that and add some more states, specifically the aerial states, so that we may be able to jump around. And we also add the animation states so that our character is properly able to be animated as we move him around. So without further ado, let's continue. The first thing I'm going to do before I touch anything else is click on the Sprite node and increase the scale by approximately 1.5 by 1.5. And then by extension, in doing this, I need to click on the collision box and adjust this to fit the Fox's sprite. Now the reason why I'm doing this is because I realized that from other videos, the sprite for Fox was a bit too small. Now that we've done that, we can finally dive into the code. And the next thing we are going to be working on is our aerial states. Alright, so before I continue, you first need to know how jumping works in platform fighting games. The way jumping typically works in platform fighting games is once you've pressed the jump button, you will enter a state called the JumpSquat state. And this JumpSquat state has a certain amount of time or frames that it lasts for. So I think in Smash Ultimate, every character maybe has a 3-frame JumpSquat, if I'm not mistaken. That might be wrong. Maybe that's Smash Melee for Fox. But the way the code works in that game is once you enter the JumpSquat frame from pressing the jump button, if you are still holding the jump button, then you'll do a full hop. That's like a full jump. Then, if you're not holding the jump button by the time the jump squat is over, you will do something called a short hop. And a short hop is when you do a lower jump, then a full hop. Quite simple. So for us to program a jump squat, there is one thing that is quite important. And the thing that is important would be for us to require the number of frames that our jump squat will last for. Alright, so from here what I'm going to do is I'm going to go to the Fox's script, and under dash duration I'm going to make a separate block of text, and I'm going to add this code. Var jump squat equals 3. I'm going to give Fox a 3-frame jump squat. We should also add notes to our code just so that we understand what's going on in the future. So I'm going to write out some code, or I'm just going to write out some notes. Alright, so now that I've added some comments and I've organized the code so that the frame was down here, now it's up there, the velocity and the dash duration is on the ground variables, just so that you can understand the basics of what's going on here. I've added the jump squat variable, so now what I'm going to do is go back to the state machine and actually implement the code for the jump squat. Alright, so here's the code you're meant to paste. If you want access to the code so that you can copy and paste it, check the description where all the files and folders and all of this is available for you to copy and paste. Alright, so the main line of code that I want to highlight to you is this one over here that says that if parent.frame is equal to parent.jumpSquat, all of this will be executed. Remember, parent.frame is up here, and what parent.frame is looking at is basically the counter that we are using so that every frame it will increase by 1. So if let's say you start an attack on frame 0, this frame counter over here, frame equals 0, is meant to increment, as you can see over here. So what we are saying is that if our frame counter is equal to jump squat, then all of this will execute, aka saying that on frame 1 nothing will happen, on frame 2 nothing will happen, but when frame 3 happens, that is when we enter these states. And what this is saying is that if you're not holding the jump button by the time the jump squat duration is reached, you enter the short hop. If you wanted to enter the full hop, then you need to still be holding the jump button. And so I'm going to show you the code for both the short hop and the full hop. Alright, and here's the code for the short hop and the full hop. It's quite self-explanatory. You're going to be propelled into the air. The frame timer is going to reset to 0. This function over here, what this does is reset the frame to 0, as you can see, and then return to the air state. Now we haven't actually added the air state, so we can do that now. copy and paste this and change it from crouch to air. I like to do it in full capitals. And then under crouch, I'm gonna copy and paste these and then change the name to air. And then now I'm gonna show you the code for when you're in the air. This is gonna be, I think, the most complicated part of this video. Alright, so this part of the video is gonna be the most complicated because for the air state, we're actually only gonna have to put in one function. And this function is gonna look something like this. This function is gonna go under everything, so it's not gonna go within the get transitions function or anything like that. It's gonna go underneath everything as a standalone. And then what we're gonna do is copy this function and put it inside of air. I'm going to explain what this does later, but I just want to continue with the tutorial. This does a lot of stuff right here. You can have a look at it and try and figure it out on your own, but I'll probably explain this in like a few minutes. And so moving on from here, the next thing that's naturally important for us to do is add a landing state so that we can land. So I want to add a new state for this landing. And then go to the bottom, add a new state. Make just look better. Okay, and we're going to call this landing. And this is going to be quite similar to air movement, where it will have its own code, its own function that it's going to run. And similarly to before, with the JumpSquat state, before we add anything to the landing state, we must go to the Fox character and add some new variables that I shall explain. These variables are the landing frames and the lag frames. And so the difference between this is between the two is that in Smash Bros or any other platform fighting game, some characters, if they jump and they land, there was actually a lag or a delay from when they land to when they are allowed to act. In Smash Ultimate, I'm pretty sure that if you jump and you just land, you can act immediately. Whereas in some platforming games, if you jump and then you land, there's maybe 1 or 2 frames of lag or delay. And so that's what the lag frames represent. This can also apply to things such as when you're doing an air dodge, for example, the landing frame. The lag frames is stuff that is added onto your landing frames. For example, if you jump and then you air dodge, your landing frames may be 5 frames. It might take you 5 frames before you're allowed to act out of that. On top of that, if let's say you do an up special as Fox, the lag frames from that may be 15. So if you do up special and you end up landing on the ground as a recovery, you may have to be inactive for 15 frames on top of the 5 frames that you also require for you to get up. So then altogether it's 20 frames. And so this is what these two variables are for, and it will be a part of the landing frame or the landing state. Alright, so here is the landing frame. I keep saying frame, I meant to say state. Here's the landing state. I'm going to explain this in a sec. This is the code for the landing state. If I scroll all the way down to the bottom like I did with the Airmovement function, we're going to add 2 more functions, and we're going to call this landing and falling. I'll scroll to the side. Here, let me actually fix up on, you can keep these the way they are because we're going to add these in later videos, but for now, so that the script works with what we are doing, I'm just going to change it so that it only says stand, like so. But yeah, I'm going to explain this in a second. You're going to understand why I had all these other states within this array. And one last thing that I want to add is under get transitions. We can get rid of this now, but I want to add this. This is very, very, very important, and I can explain this briefly in a second. So you want to have these two: if landing equals true, etc., if falling equals true, etc. Then you want to have these functions, and ultimately you want to have this within the landing state. And all of this should now work towards having your character work when you run the game. But before I run the game, I need to explain what each of these things do. In fact, before I go on to explain what I was trying to talk about, we need to go back to the Fox script, and I want to add in a new category of variables. So these are going to be called the onReady variables. So I'm just going to copy this. Oops. Paste that over there. Call this onReady variable. This is what's going to be necessary for our falling and landing state to be working. When I say falling, there isn't necessarily a falling state, but you'll understand when I explain all of this. And so what this is doing is it's looking at the Raycast and it's trying to utilize the ground L and ground R Raycast. We need to go back in 2D and we need to actually set up the location for these Raycasts, and we need to enable them. So I'm going to enable ground L and ground R, and then go to left Raycast, and I'm going to change the casting to 10. Same for the other one, 10. And we're gonna move these to the feet of the fox character, so somewhere around there, so that the tip of the Raycast is barely touching, you see that, barely touching the ground. Another thing that we need to do is go to the ground L and ground R Raycast and change the collision mask from the player and change it to the walls. So from player to the walls and to the platforms. That's what the Raycasts are going to detect. So moving on to the explanation. Okay, so there's quite a few things that I have to explain here. The first thing I want to explain is the JumpSquat state. This is quite self-explanatory and I talked about it quite a little bit. But parent.velocity.x with this lerp command that's built into Godot, what this does is it makes sure that as you're jumping, your character's momentum does not completely stop to a halt. So what this is doing is it's slowing down your character's velocity towards 0 at a certain rate, and mine is doing it I think at 8% every frame. And so it's doing the same thing whether it's a full hop or a short hop. Moving on to the landing state, this is quite complicated, but it's generally the same thing. This first if statement is checking whether or not the parent's frame, the frame that the character is currently on, is less than or equal to landing frames plus lag frames. I explained this briefly earlier as well, but this is basically checking to see whether or not you are still landing. If you are still landing, then on the first frame nothing happens. But then after that, so if let's say the landing frames is maybe let's say 10 frames. After the first frame from 2 to 9, you're going to be slowing down. So parent.velocity.x equals parent.velocity.x minus traction of the parent character divided by 2 is basically saying that let's say you're moving horizontally really fast and then you start to land. Your character is going to slow down at a certain rate, and that's all this is doing. And what this is doing is making sure that if let's say you're moving in the right direction, when you slow down, your velocity will only decrease to 0. It will not go below 0, because if it went below 0, you'd end up moving to the left. Moving down to the Airmovement function, this one is very, very complicated. What this does is it makes sure that when you put this within a state, it makes sure that your character will have aerial mobility. For example, during an up air, there is aerial mobility. You're not going to be moving in the air as if you're moving on the ground. It's the same for if you're doing a down air or any other aerial attack. And so what this is saying is that if your vertical velocity is less than the falling speed, you want to increase the falling speed. Now remember, in Godot, the y velocity is actually inverse to what you might know in maths. In maths, the positive direction for the y axis is up, but the positive in most programming in most game engines is down. And so if the positive is down, you want to increase the fall speed if you're not falling at the same rate as the falling speed, which is determined over here. And so what you are saying over here in the next line is you're saying that if you press down And I actually don't have a buffer system yet, so I can get rid of this for now. We're going to add that in later. But if you press down and your velocity is more than this number, this is just an arbitrary number that I found through tinkering around, this should probably be a value, and you're not fast falling already, then you're going to instantly hit your max fall speed. This is how you fast fall. This right here is how you fast fall. Then you will have a function called fastfall that I'm not sure if I added. Yes, this is something that I will need to add. I can just do it right now. I can say, I might want to, yeah, I'll add it on the air variable. So var fastfall equals false. That was one word. Let me change that. There you go. And so what it's saying over here is if fastfall is equal to true, what this is something that we're going to discuss later on. But if you do have any platforms, the fox character won't be able to actually land on those platforms because he won't be detecting it anymore. Moving on, if the velocity.x is more than max airspeed in either direction, then what that's going to do is first of all going to check if you're moving in the right direction or in the left direction. That's what velocity.x being more than 0 means. This is to the right and this is to the left. And so it's basically doing the same thing on both sides, but inversed. So if you're moving to the right and you press the left, you start moving to the left. And if you press right, then you'll continue moving at the same velocity that you're at. And it's doing the same thing to the left, but in inverse. So if you're moving to the left and you press to the left, you're still going to be moving at the same velocity. If you're moving to the left and then you press right, then you will drift to the right with air acceleration value, which is somewhere here, what, 25. Then let's see what this is saying. This is basically saying that if your movement is less, or if the speed that you're moving at is less than the max airspeed, then if, let's say, you are moving to the left and you do press left, you will increase moving to the left. And if you move to the right and you press to the right, you will increase moving to the right. This is very simple when I break it down, but it has to be its own function, because otherwise you'd have to copy and paste this code for every other state that would require aerial movement. And last but not least for this one, if you're not pressing left or right and you're moving, let's say, to the left, as this suggests, then your velocity, your air acceleration is, you're going to be pushed with air acceleration, but it's going to be divided by 5. So you're going to basically, you're going to slow down slowly. That's what this is saying. It's basically saying you're going to slow down slowly. So if you're moving to the left, you're going to slow down slowly until you eventually reach a stop. If you're moving to the right, it's the same thing but inverse. So if you're moving to the right and you're not pressing anything, then you're just going to slowly move to the left to the point where you stop. Okay, moving on to landing and falling. For the landing state, this is going to use our states include function that we added in, I think, in the 2nd or 3rd episode. And this is basically saying that if you're within any of these states, as you saw earlier in the video, there were more states that I had here, but if you're in any of these states and the raycasts are colliding and you're moving downwards, then what this is going to do is it's going to get the collider, which is the raycast, is actually a function or a variable of the raycast class. So if I click on it, you can get, oh, you can't actually, that's weird. But you can go in the documentation, search for help, and do get underscore collider over here, and then you can read about what it does. Well, this is basically the object that the raycast is colliding with. So what it's going to do is it's going to get the collider, and it's going to reset the frames to 0, and it's going to say if your frame, if your vertical velocity, aka if you're moving down and you end up touching the ground, your velocity is now going to be 0, your fast fall is going to be false, and it's going to return true. It's the same thing for falling. If you are falling, this is basically going to make it so that if, let's say, you're in a state such as standing and somehow underneath you the ground disappears, if you're in any of these states standing, I can probably add states dash as well. This is probably another one to add. If your raycasts over here are not touching the ground, then also return true. And the reason why we're returning true for landing and falling is because up here within get transitions, what we are saying here is that if any of these return true, then it will activate a certain state. So for example, the landing state or the landing function, if the raycasts are touching the floor as you are landing and that is true, reset the frame and return states.landing. And remember, return states is how you're going to change from one state to another. So no matter what state you're in, whether you're doing an aerial attack, whether you're doing, let's say, side B with Fox, for example, if it is included in this list and the raycasts are touching the ground, then you're going to return to the landing state. If let's say you're standing or you're dashing or you're doing a down smash, an up smash, a down tilt, whatever attack you're doing in the falling with the falling function and it is true, then you'll return states.air and you'll be in the air. So that's about it for the explanation of each of these functions and these states. Now, before I actually start the game and show you what the game looks like now, I just want to introduce one more piece of code that's very self-explanatory that you should be able to understand. Just add this in. It's basically just saying if you press the jump button, you're going to reset the frame to 0 and you're going to enter the JumpSquat state. Another thing we must do is go to the project settings, go to jump and add a jump button. For me, I'm just going to do W since that just makes it easier for me. You can change this to anything you want. In a future video, I'll go through how to add changing your inputs. So you can have jump for W or have jump for space, but you can change it. I can do a tutorial for that. But yeah, once you've done that, you save, you go back to the main test stage, and then you run the game. And as you can see, my character is moving about. And the main thing that we want to test is the aerial stuff. So as you can see, my character is able to move around. You can't really tell that the character is dashing. And that's because we're missing one more thing, which is the animations. Okay, so if you want to get the animations working, we're going to have to use the enter state function. The enter state function, as opposed to the get transition state, only runs once you have entered a state, whereas get transition runs every single frame whilst you are within a state. So for enter state, you just want to say that once you have entered a state, play the animation of that state. And so you can just copy the code here or check the description so that you can get access to all the files and folders up until this point in the tutorial. And so what this is basically saying is that if it's going to look for the state, and if you're currently in the state of stand, for example, you'll play the idle animation, and the parent.states.text will equal stand. So if you look at your character, the label, this text over here will actually display the name of the state that you're in, just in case you want to fiddle around with the states. Also, you just want to see if everything is working the way it's meant to be. And so what this is saying is it's going to go to the parent, then go to states.text, which is over here, which I just reorganized. It was down here before. And it's going to change its text to stand. Now, play animation is actually something that we don't have yet. So all we have to do, go to Fox, maybe go down here, make a new function. So you make a new function, we're going to have the animation underscore name. And so under, what we're going to do is we're going to say anim.play and then animation name. Now we don't actually have a variable as it's going to indicate here, so all we have to do is create one. So all we have to do is say on ready var anim equals the animation player, and now everything should work. So all I have to do is play the game, and as you can see, the animations are working. The dash animation looks a bit weird because we haven't actually set up the run animation, which is going to come in the next video. But yeah, everything else works fine. The jumping works fine. You can see that the raycasts are working. And so for me to fix this idle animation, the reason why this is happening is because if I go to the animation player, I forgot to make this repeat itself. And for the dash animation, I think I might have actually made it so that it does repeat itself when it's not meant to. So now if I play the game, everything should work as it's meant to. And so you can see it's not doing this weird, you know, repeating itself and all that. That's it. That's pretty much it. For us to fix the dash dancing, which is something I said I was going to do in the last video, but I ended up forgetting to do, all I have to do is go to the dash state and say if you're pressing to the left whilst you're in the dash state, then parent.turn is going to be false. And then if you press right, then parent.turn is going to be true. I think this may be the other way around, but we just find out. Yeah, so that's false. So all I have to do is change this around. False and true. There you go. So now my character's properly dash dancing. And that's it. That's pretty much it. That's all you really need for you to have your animations working. So for every single state, you just want to make sure that this is what you have. And so that will be it for this tutorial. In the next video, we'll go through adding more states, things that are more complicated like moonwalking, turn states, running, walking. These are things I'm going to add in the next video. And so if you enjoyed the video, don't forget to go to the Patreon where you can get access to all the files and folders, as well as access to my Discord server where you can get help and support. And so without further ado, I'll see you in the next video. Peace.